Hi everyone, today we're going to talk about how to solve systems of equations using the method of substitution. So if you remember from class last time, we solved systems of equations by using the method of graphing. And that solution was found by looking to see where the two lines intersected. So we're looking for that intersection point. Well, we're going to do the same thing here today, but this time we're going to do it algebraically instead of graphically. Alright, so before we can go into the actual work of solving those systems, we're going to do just a quick review of how to solve a literal equation, or an equation that has more than one variable in it, and solve it for a specific one. So let's take a look at this first one here. Alright, 5x plus y equals 10. And they want us to solve it for y. So our job is to solve this equation, or isolate the y. In order to do that, we need to subtract 5x from both sides. Now remember, we cannot actually subtract 10 minus 5x. We are just going to write them next to each other. So this one, I end up putting my x term first, just because that puts it into slope-intercept form. All right, so y equals negative 5x plus 10. I'm done at this point. I have solved the equation for y. All right, let's look at b. This time we want to solve for x. So in order to solve for x, I need to move that negative 3y over with the negative 6. So to do that, I'm going to add 3y to both sides. My 3y's will cancel out, and I'm left with x equals 3y minus 6. So again, I just brought my y term down and then took the top term and put that over to the side. In this case it was minus 6, or negative 6, so I did minus 6. It's done because I've now solved for x. X has been isolated, it is by itself. Alright, let's take a look at c. This time we need to solve for y again. Pay attention because in front of y is that negative sign, or the subtraction sign. So we're going to include that with the y. It really means there's a negative 1 there. Alright, let's get that 2x over to the other side by subtracting. We're left with negative y equals negative 2x plus 12. So remember we said that that's like saying that there is a negative 1 in there. So we can add that 1 if we really wanted to. Okay. And so now, to get rid of that negative 1, we can divide every term by negative 1. So every term will get divided by negative 1. Okay. Cancels those out, and now we're left with y equals 2x minus 2. We've now solved the equation for y. Alright, let's do this last one. This time we need to solve for x. So in order to do that, first I need to move my y term over to the other side. 8y's cancel out. I'm left with 4x equals negative 8y plus 16. Now I can divide every single term, if I can find it, by 4. So every term is going to divide by 4. Those 4's cancel out, and we are left with x equals negative 2y plus 4. Alright, so that is a skill, it's a review skill, but we will utilize that later on in this lesson. Alright, so now let's come down here and look at how we solve a system using substitution. So think about what that word substitution means. Substitution means to replace. And we're going to replace something with something else. So, first thing we need to do is look at the equations and decide, do we already have one of the variables isolated? So when I look at these two, okay, I'm looking for a variable that's completely by itself. And in this case, I do. This first equation, that y is completely isolated. It's by itself. Right? Y equals x plus 1. So what we have going on here is this says that y has a value of x minus 1. So we're going to take these two equations, and so I took the y equals x plus 1, put that here. My 2x plus y equals negative 2, I brought that down. You're going to notice I put a 1 in front of my y. And that's just because y has a coefficient of 1. It's going to serve a purpose once we get going. All right, so we have determined that y has a value of x plus 1. They have the same value. So what we're going to do, since y and x plus 1 have the same value, I can take that x plus 1 and I can substitute it in for y because they have the same value. So I'm going to come up here and I'm going to take this equation here and I'm going to change or replace the y with the x plus 1. You're going to notice that I put it in parentheses. Whenever we substitute, we should use parentheses. Alright, so now let's solve this equation. Now, instead of having two different variables, we now have just one. Alright, so the first step, in parentheses, I need to distribute. So I'm going to distribute the 1 to the x and then to the 1. My next step is to combine like terms. So 2x plus 1x will give me 3x. Where'd it go? Oop. Forgot it's over here. Alright, so there it is. 3x plus 1 equals negative 2. Alright, so now I need more space. So now I'm going to take this and I'm going to bump it up to here, just so I've got a little more space to work with. Right. I'm still trying to solve for x. I'm solving this equation for x, so the next thing I need to do is subtract 1 from both sides. That will cancel my 1's out. Now I have 3x equals negative 3. Okay. I need some more room, so now I'm going to take this and I'm going to bump it up to here, just to give me a little more space. Okay. Now to solve for x, I'm going to divide, maybe. I don't know why it's not working. There we go. And divide both sides by 3. 3's cancel out. And we are left with, oops, lost my thing. Alright, my 3's will cancel out, and we are left with x equals negative 1. Alright, once we found our x value, now we can go to step 3 and we can find the value of y. So to do that, we're going to take this x value here that we've already found, and we're going to substitute it back into one of these two equations. Okay? It really does not matter which one. I'm going to tell you right now, you want to make this as easy as you possibly can on yourself. We're trying to solve for y. We want to figure out what's the value of y. Well, if we look at this first equation, the value of y is equal to x plus 1. Well, we now know what x is. So this first equation would be the easier one to substitute it into. So I'm going to take that equation, y equals x plus 1, and I'm going to replace the x with negative 1. I'm going to take care of the math, and now we find that y equals 0. So now we've found our x value and our y value. So now we can write our solution as an ordered pair. I've got my x equals negative 1. My y equals 0, so as an ordered pair, it would be negative 1, 0. This is our solution. This would be the exact point that these two lines would cross. So they're both linear equations. The first one is set up ready to go for graphing. The second one is in standard form. You could graph with your intercepts, right? But these two, if we graphed them, would intersect at this point right here. Alright, so now let's check our solution. How can we check that? Well, we're going to take those two equations and we're going to substitute this ordered pair into both of them just to make sure that it does work. So I'm going to start with the y equals x plus 1. my y is 0, my x is -1. And then I'm going to check, does -1 plus 1 actually equal 0? And it does. They equal each other, so that ordered pair works for this first equation. Now we're going to check it for the next one. So again, same ordered pair, going to go in for the x and the y. Now I'm going to do the math. 2 times -1 plus 0. Checking to see, does it really equal -2? And it does. So now we're done. Okay, so this was just our check if we wanted to check answers. We could also pull this up in Desmos and just graph those two equations just to double check them. In fact, let me show you that. Okay, so to check this in Desmos, we'll open up Desmos and we'll type in our two equations. Remember, the nice thing about Desmos is the order that the equation in doesn't really matter. Right, so this one was in slope-intercept form, and it graphed it perfectly for me. Right, now I can do the next one, 2x plus y, whoops, 2x plus y equals, and it was -2. Right, and I'm just using my keyboard to type all of that in. You can always come down here and pull up this keyboard and use your mouse to click on everything, or you can just use your standard keyboard. All right, and now we can just double check, where do these two lines intersect? Right there at -1, 0, which is the exact answer that we were able to come up with. All right, so two different ways to check your answers. All right, so let's come over here, and I want you to go ahead and try this problem on your own. Go ahead and pause your video now. All right, now, many times you'll have to isolate a variable first before you can actually do any substitution. It doesn't matter whether you isolate x or y, you should begin by deciding which equation has the easiest variable to isolate. So here all we're going to do is look at which equation should we use to isolate a variable, and then which variable should we isolate. So what we want to look for is a variable that has no coefficient. Makes your life a little bit easier. So when I look at the first equation, 3x minus 4y equals 1, I'm going to look for their coefficients. X has a coefficient of 3, y has a coefficient of -4. Alright, so neither of those are going to be very easy to isolate. Let's come down to this one. X plus 4y equals 3. X has no coefficient, or a coefficient of 1. Y has a coefficient of 4. Right, well, let's do this one because we wanted to look for a variable with no coefficient. So that x is the variable I want to solve for. So if I want to solve for x, that means I need to take that 4y and move it over to this side, to the 3. And to do that, I'm just going to subtract 4y over. So now I get x equals -4y plus 3. Let's do the same thing on this one. So which equation should we use to isolate a variable? Well, again, I'm going to look at each variable and its coefficients. X has a coefficient of 2, y has no coefficient, or a coefficient of 1. X has a coefficient of 3, y has a coefficient of -2. So the only one with no coefficient is this y. So I'm going to use this first equation and I'm going to solve for y. To do that, I need to take that 2x and subtract it over with the 5. So we're left with y equals -2x plus 5. Okay. All right, so now let's come down here. Okay, so now we have to pick, and let's take a look. And first thing we want to do is check, do we have an equation with a variable that's already been isolated? And in this case, we do, the first one. Okay, the y has been isolated, so now we know that y has a value of x minus 3. I'm going to take that x minus 3 and substitute it in for y. So my x minus 3 is going to go in for y. So the first thing I'm going to do is rewrite that, and I'm going to give that y its coefficient of 1, because I need that to distribute. So now I get the negative 4x plus the coefficient of y, which was 1. And then I'm going to replace the y with the x minus 3 equals negative 9. All right, to solve, I'm going to distribute. And then I'm going to combine like terms. Negative 4x plus 1x gives me negative 3x. Now, to solve this equation for x, I'm now going to add 3 to both sides. 3's cancel out. We're left with negative 3x equals negative 6. And now to solve for x, I can divide both sides by negative 3. And we are left with x equals 2. All right, now that we have our x, we're going to take it and we're going to substitute it back into either of these equations. One of them is going to be easier. Since we have to solve for y, why don't we just pick the equation where y is already by itself? So now we're going to use the equation y equals x minus 3. We're going to take that 2, substitute it in for x, and then we can do the math. Y equals negative 1. So we found our x value, we found our y value. My solution is 2 comma negative 1. We write it as an ordered pair. Because remember, this is just like those graphs, we're looking for where do they intersect. We're looking for that ordered pair of where they intersect. We're just doing it in a different method. All right, let's try example 2. Okay. So I'm going to pick the equation that already has a variable solved for itself. In this case, it's the second one. My y has already been isolated, so I'm going to take that x minus 1, and I'm going to substitute it in for the y. Okay. So this time, y has a coefficient of negative 3. So I'm going to leave that there, substitute in my x minus 1, and now I can go ahead and solve for x. First thing I need to do is distribute the 3, and then I can combine my like terms, so 2x minus 3x will give me the negative 1x. To solve for 1x, or to solve for x, the first thing I need to do is subtract 3. Maybe, where is it? There it is. Subtract 3. Okay. And then we are left with negative 1x equals negative 4. Now I can go ahead and divide both sides by negative 1. And we're left with x equals 4. Make sure you're really careful on the distributing. When that outside number has a subtraction sign in front of it, it means that's a negative 3. And inside, that means it's a negative 1. So a negative 3 times a negative 1 gives me a positive 3. All right, I found x. Now we need to find y. So we can go back up, use this equation where y is already solved for itself. Substitute 4 in for x. And then we end up with y equals 3. So my solution is going to be the ordered pair of 4, 3. Whoops, I forgot to fix this one. I had a mistake earlier, and I fixed it except for this one piece. There we go. Now it's fixed. And there's our solution. All right, one more, and then you're going to do the last 3 problems on your own. So here we go. All right, this time, we're going to have to do a little bit of work before we can actually substitute. So neither of these equations have a variable solved for itself. So we need to do that first. So up here, both x and y have coefficients. So I probably don't want to touch that one. So instead I'm going to come down to the next one. X minus y equals 13. Technically, neither of them have a coefficient. X does have a coefficient of positive 1. Y has a coefficient of negative 1. We're going to solve for x since it's positive and we want our variable to be positive. So solving for x would be one less step. Right, so first thing I'm going to do is I'm going to add that y to both sides. And when I do that, I have x is equal to y plus 13. All right, now that I know what x equals, I can take that value and I can substitute it into the original equation. I'm going to substitute into this one up here for y, or for x, I mean. X has a value of y plus 13, so y plus 13 is going to go in for x. Right, now we can work on solving. Let's distribute the 4, so we get 4y plus 52 plus 2y equals 10. Next we can combine like terms. 4y plus 2y is 6y. Now to solve for y, I can subtract 52 from both sides. I'm left with 6y equals negative 42. And now I can divide both sides by negative 6, or I mean just by 6. And then we're left with y equals negative 7. Now we need to go back and we need to find what our x value is. Well, we've already done the work. We've already found an equation to figure out what x equals. So x is going to be equal to my y value plus 13. My y value is negative 7. So I'm going to substitute negative 7 in for y. And we learned that x equals 6. So my ordered pair, be careful on this one. We started with y, ended with x. Remember, an ordered pair is always x and then y. So 6 comma negative 7. The x value first, y value second. All right, that's all that I have for you. I need you to go ahead and make sure you do all the try on your own. So there's a total of 4. Make sure they are completed before you come into class next time. I'll see you in next class.